Okay, now we're on live. Let's start class. Okay, we're on live. Stop talking. Your secret. It's broadcasting. Okay. All right. So we were talking about. We'll stop at the point that's talking about the delegation. Okay, like the task-driven design. Okay, but that might be too it might be a little bit confused. You might be confused that part because it's maybe too theory. Okay, so instead of going that direction, today we'll talk about something else first, then we reach there again about this task driven design. Okay, so today we will start actually use a textbook a little bit. I don't know if you have got the textbook somehow, some way. Like, yeah. So I have a textbook here, electric version, but I cannot share this. I can only use it in class, but I cannot share that. So it's better to have your own textbook. Okay. If you really want to know what I'm talking here. Alright. So it's about well-designed software. Well-designed software. Okay. It's actually pretty much, this is a good example on this, a good example on the textbook. This guy. Okay. Maybe I should make it larger. It's okay. I can just explain. Okay, so this guy, he owns a guitar shop, and before he got this idea, she's like managing all his system, all his inventory, with a paper-based method. Okay, but suddenly one day somehow he got an idea. Maybe he need to use some computer to manage the inventory. Probably because he got a big inventory or he's messed up with his paper writing stuff. So anyway, he wants a inventory system that help him to manage his guitar shop. Okay. So here, if he invites you, maybe you are his friend or someone he know that he can help him. If he invites you to design a management system for his guitar shop, what will you do? Think about the process of a guitar shop. A customer get in and the customer wants to find some guitar, right? And then the staff trying to check if we have this guitar, compare with inventory and say if we have something there. Yeah, some kind of activities in the guitar shop. Okay, what will you do in this system? What functionalities do you think this system should have?
First and foremost, we need to have a class that will store, have the collection of the types of guitars.
Yeah, let's forget about the class for now.
Okay.
Functionalities. What do you want to do with the system?
Search.
Search. Yes.
Store the data for the guitars.
Store the data. That sounds like a database, something like that, right?
Inventory.
But yeah, inventory. Okay, first search, inventory. If you want to manage that inventory, you have add, delete, modify, edit. Yeah.
You have to add.
Yeah, add. Yes. So manage the inventory. You add, you delete, you modify some entry in the inventory, right? Anything else? Search, yeah, he mentioned search. I think that's sort of the key functionalities in the system, right? Yeah. Okay. So yeah, pretty much those functionalities. Maybe a GUI or some other functionalities, but the key is we have the inventory we can manage. and we can search the inventory for the custom needs. Okay. So here's the thing, right? Somebody did this application for his store. That's the first version of this application, but you can guess this must be a horrible design. Otherwise, we won't talk about it. I won't call it first version, right? So yeah, I can tell you it's a horrible design. But what's so horrible? Let's see. Okay. Okay, I assume you all know more or less about UML class diagram, right? So basically there's two classes. On top is the name of the class, attributes of the class, and yes, the functions, the operations. Yeah. So we have two classes. One is called guitar, one is called inventory. So each guitar in Rick's inventory is represented by an instance of a guitar. That's right. And let's see what's included, right? So it makes sense. It has a serial number, price, and some other information, builder, model, type, and the material, backwood, topwood. Anyone play guitar? Okay. All right, no problem. That's okay. You do? Oh, that's cool. Yeah. So yeah, we will have some sort of wood there. Maybe you can help us explain later. Okay. So we have functionalities get all those information, right? And one set price. Yeah. Set price. We set. Yeah. And probably we set price. We have set price here, maybe because yeah, yes, price it change and change a lot, but serial number no. So all those other attributes like serial number, builder, model, all those things, where do we set them? Probably it's in the builder, like the builder function of a class. Everyone knows what is a constructor of a class, right? Everyone knows that. Okay, so I won't explain it. So constructor is like when you knew some class, that constructor is called. Okay, so you can create this class there. Okay, probably most of that. So guitar part. Okay, seems okay, right? The variables, the method. And let's look at the inventory. We have a list of guitar that currently in the store available. And we have a add guitar, get guitar. Maybe we have a remove, maybe this is not showed here, but here we have those three functions: add guitar, get guitar, and search for some guitar. Yeah. So the get guitar has some explanation here. The add guitar, it's take all of the guitar's details and add it to the inventory, add to that list. And then we get that guitar, takes the guitar serial number, return the guitar's object, and search for guitar. So if I ask you to design a search function, what would be the input and output you're expecting? The output must be a guitar, right? No, actually no. Yeah, the output has to be somehow related to guitar, yes. But Should it just be a guitar? Let's talk about that later, okay? But okay, the output is something related to guitar. All right, but input, what should be input of the guitar?
Should be able to define variables. I mean, you might want to search by a price or by the model, or maybe they want a certain type of backwood, so you should be able to use any of those.
Yes. So right here it's giving a variable of guitar. So actually all the information you mentioned can be included in that instance. So I think here it's okay. Just give it guitar function, and probably when you give the guitar instance for the search, you include builder, model, type, but not the price or serial number, right? So do the search. So looks like this design, it will have the functionalities there, right? Okay, looks okay, yes, but there are a lot of it violates a lot of principles, and we call it maybe not that horrible, but it's not a very good design here. Okay, let's see. Here's some implementation here. Let me briefly introduce that. Okay, this is a simple, it's a guitar. It's just a guitar. It looks more like a data structure, right? We have some members there. Okay, serial number, builder, model, type. It's here. Model type, backwood, topwood, and double price. It's a double, yes. And this is the constructor I mentioned. When you create a guitar instance, you call this. You give a serial number, price, initial price, builder, model, type, backwood, topwood. Okay, and then you assign the value. And this is a get function. All those get function, the set function. Okay, that's a pretty simple one. Easy to read and understand. Yes. Let's look at this one. So this is the inventory. Okay. So in the constructor of the inventory, it creates a linked list for the guitar list. Makes sense, right? And this is a 8 guitar function. Just take you give all those serial number, price, builder, and you new instance, create an instance, and add that to the list. Okay, so far so good. And get guitar with serial number, just loop through and find that guitar. Let's look at this guitar search function. How they implement this search. Well, it looks pretty complicated, but actually only 2 things it does. It did only one thing. Just loop through and compare each of the attributes. Okay. If that match, if that doesn't match, if there's no match, then we skip this current object. Skip this current object. We go to the next loop to see if we can find another match in that list. Okay, so that's all this search function do. Okay. I think here it miss from my observation. We need to, after this continue, we need to have a return function for what? We need to return guitar here. Do you think so?
Yeah.
Look at this. Right? skip. If we do this, nothing will show. Nothing will show because it's always continue or return null. It's not gonna return any guitar here. The thing we want to add one statement here to return guitar is once it meets all this criteria, we can return that guitar. Okay, good. So I think that's a typo of print error. They just missed that. Return statement. Okay. So here, okay. So Rick's pretty happy. He has this new system to help manage his store. However, then Rick started to lose the customers. Okay, so it seems like no matter who the customer is and what they like, Rick's new search program almost always come up with empty when it looks for good guitar matches. Yeah, but sometimes Rick just knows he has a guitar that they need. It's not because it's forgot to return. That's the print error. It's because of the design. Okay, so think about yourself. Think yourself as a customer. When you get into the shop, you want to look for a guitar of certain type. First, you want to it's not only guitar. If you want to search for some product online shop, first you want to specify the brand, right? And then it's maybe for the guitar here, the level, maybe it's a start level guitar, and the type, maybe electric, and the elder is the wood, type of wood. Can you explain what is an elder? The wood? No? Okay, but it's some sort of wood used in the starting level electric guitar. Alright. So this is a test case that one of the customer who look like this, okay, wants to find a guitar. Fender, start level, electric, elder, made of elder. Okay, so she wants this kind of guitar, and then what the system does is it creates a new guitar object, right? Remember the search function? It takes an object and search for match in the inventory. So first it creates a new guitar object here with all these variables, right? And there's no serial number, and the price is we're not using that in the search function at all. So these are the conditions for the search. Okay. So search for what Aaron likes. Aaron is the customer. Inventory search what Aaron likes. Alright. So if we find something, then we output information. And else we print out Aaron, we have nothing for you. Alright. So in this case, Aaron got nothing because he got this. Aaron, we have nothing for you. But let's look at this. Rick knows there's something there because he once called this function inventory dot add guitar, serial number, price 1.5. Oh, that's pretty expensive one, right? I don't know, 1.5, is that expensive guitar? Could be, right?
think it's more than that. I think it's 14.99.
It's 49. Yeah, 49.99. It's 1,500. Okay. And that's the condition here. Fender, start coaster, electric, elder. Okay. It's search, but find nothing. So what is wrong there? Do you think so? Think back to the search function.
Yes.
Something's not aligning right.
Yes. Let's see. Let's see here. Okay, remember this. And let's look back. Let's look at this again. Yeah, let me do this. Okay. I cannot show them both of them at the same time, right?
That's because
You find it?
it's taking strings that, and so you can misspell, or you can spell the word with like lowercase letters.
There's no misspell. There's no misspell.
Well, the Fender up there is it's lowercase.
Yeah. Yes. That's the case there.
Cases.
It's defined here, right? So when you actually specify somehow you specify this brand, okay, you kind of start with this F uppercase. Sometimes you forgot to do that. Or sometimes if it's iPhone, okay, it actually starts with lowercase,
Yes.
right? So, right. Actually, most of the Apple product, it starts with I's, blah blah blah. Yeah. So you cannot expect every customer to like remember the case thing, right? So we find a problem. We find a problem here. The problem, what result in this arrow is a case. It's a case. So if I want, let's look back to this search function. If is this search? Yes. If I want a solution from you, like fix this bug, what would you do? Yeah, ignore the case. And yes, ignore the case. Yeah, that's the problem is a case. Of course, we just ignore the case. Yes, a lot of a programmer or will think this way. Like we find a problem, we identify the problem, then we just fix this problem. Right. That's basically most of the time our first response to this bug is like this. Okay, it's just a case problem, so we can just, when we're doing the compare, we can just ignore the case. We are doing the conversion, we put all the letter to lowercase, and then we compare, we use the equal. They use this dot equal in the Java string, dot equal, so it's case sensitive. And Java also have a function that's string dot to lowercase. It will convert everything to lowercase, and then you kind of compare. Then there should be no problem. Yes, so that actually it will fix this bug. Yes, for sure.
Well, yeah. Wouldn't it be better to give them just a small selection of options to choose from instead?
Yes, small selection of options. Yes, that's a good way. Yeah. So what was your question?
What if the problem was you didn't specify the serial number?
serial number is basically ignored here. It's not compared at all. Let me see. Comparison starts with a builder model, type, backwood, and topwood. Yeah, so serial number is ignored. Okay, so you come up with the idea that give them a selection and kind of restrict the selection. So I think you have that idea because you use all those online systems. They provide you with this option, right? However, if we're not thinking that way for this particular application, for sure, the most nature first response is we just do this case, fix it, and then it will work. Will it work? Yes. But this is a design course, right? It's not a programming course where just play with this program. It is a design level. So we kind of want to solve the problem going to an upper level. Okay, into an upper level. So let's see here. Yeah, that's the first thing you like to change. That's a thing everyone we think of okay, so we have 3 persons here trying to give their opinion to fix a problem. Okay, one is the fairly new to programming, but he's a big believer in writing object-oriented code. So he's saying, look at all those strings. See, I believe you noticed it is everything a string, like I did several years ago. I use everything as string. So yeah, because I can't think of anything can be represented as string. Even object, it can be serialized as a string. So kind of string is pretty flexible, right? But it's not a good practice from a design perspective. So look at all the strings. That's terrible. Can we just use a constant or objects instead? That's what his opinion. And another guy said this design is terrible. The inventory and guitar classes depend on each other too much, right? Because the search, it just used a lot of the guitar, like guitar get number, get price, get builder, something like that. And I cannot see how this is an architecture, but you'd ever be able to build upon. Yeah, we need some restructuring, so we can guess for this guy what is his like job or profile. What so he's been around for a while and really knows his old principles and design patterns, right? Because he's talking about the architectures, maybe the patterns of these architectures. Okay, here another girl here, always delivering exactly what the customer wants. So what she thinks is this note from the owner says he wants his client to have multiple choices. Should the search method return a list of matches? Right? That search method, the original search method is only return a guitar. Most of the time we search for a list of things. Okay. So actually all of them are making good points. Let's see why they are good points. Okay, it's not here. Others are making good points. Okay, and what's not right is that you just fix a case. It will work somehow, but it's not a best practice. Yeah, I guess this guy is the Rick's original friend. He was Rick's friend, but I don't know if he is friend anymore. But he make this job, and he don't know where to start. He said, I feel like every time I have a new project to work on, everyone's got a different opinion about what to do first. Right? Sometimes I got it right, sometimes I end up reworking the whole app because I start in the wrong place. So what should I do first in Rick's app? So he is actually the programmer or the engineer that was doing Rick's job, doing Rick's app. Let me skip this for a bit. Yeah, this is the string comparison here. This is the solution that he mentioned to lowercase, right? So you could use a function like to lowercase to avoid this problem. Right, you could do that. That will give you good functionality. But let's think about if we are trying to build a high quality, good software. Let's start from there. Let's see if using to lowercase is a good practice or not. Okay. So now let's see. What is good software? Okay. So we're trying to fix a problem from a design level. We want to design a good software. This good software, what can we call it a good software? Yeah, what do you think is a good software? From a design level, yeah. Okay, not from design level, just from general. There's a software product. What do you think is good?
Something that's fast.
First it should do what it's supposed to do.
Easy to maintain.
Yes. Yes.
Extensible.
Yes.
If the components are not too attached to each other.
Tight cohesion, low coupling.
That's cool.
Let's go.
You have touched this level, the component, the maintainable. Yeah. So first thing we need to think of is it should do what the customer want it to do. Right? It always returns value I want. Right? Great software always does what the customer want it to. So even if customer think of new ways to use the software, it doesn't break or give them unexpected result, right? Yeah, that's the first thing. First thing first, customer, from the customer's perspective, okay. However, if you think about a software product, customer is not only rule that interact with the software. We also have the builders of the software, the designers, and the builders of the software. Okay, so if we have a software in this company, most of the time it's not a one-time thing. we have this version. Later on, we have another version, and then we expand the line, product line. Okay, think about Google. Think about Google. Okay, so we think Google Documents. Okay, maybe it's a good thing, right? It's a application there. Then we have a Google, maybe spreadsheet, Forms. We have Drive. All of them, they are connected, right? It's not just okay, I want a cloud documentation software. Then we build it, it's done. It finished what I want. But later on, you need to consider to extend this product, right? So from the company or the builder's perspective, what makes a good software? It should be easy to maintain, extend, right? So from two perspectives, from the customer's perspective, of course, it does what I want, right? And this last 2 points is from the perspective of the programmer. First is the object-oriented programmer. So great software is coded that is object-oriented. So there's not a bunch of duplicate code, and each object pretty much controls own behavior. It's so easy to extend because your design is solid and flexible. So object-oriented is easy to extend, yes. And also another one is basically maybe a design pattern structure architect. So great software is when you use tried and true design patterns. That's a design pattern and principles. You keep your object loosely coupled. Sometimes you use design pattern to ensure this point. And your code open for extension, reusable extension, something like that. So basically that's 3 things we want to do. All of them are true. That's the 3 points we're trying to say this is a good software, great software. Okay, so as a summary of these 3 points, first, great software must satisfy the customer. The software must do what the customer wants it to do. Second, great software is well designed, well coded, easy to maintain, reuse, and extend. What's the difference between maintain, reuse, and extend? What is maintain?
You just kind of update some things inside there.
Updates. Yeah.
Fix bugs.
Right. Like fix bugs. It's a good maintain. Fix bugs. That's a good example of maintain. And change. Do some change. Okay. Extend is a change. Change, this word is too big. Yes, too big. So maintain, basically like you doing some to the current functionalities, to the current scope of that project. You like fix bugs, you adjust the functionalities, something like that. And extend, maybe new functionalities extended into this software. And reuse. Reuse means if we are going to have a
Maybe sell to somebody else, but just modify it, meet their needs.
yeah. Yes, that's a good example. If another store, okay, maybe it's not guitar store, it's another store. We can reuse some of those functions here. So it's object-oriented thing. Yeah. So that 2 points here, that's good summary. Actually, that's a good summary in this book. First is win your customer over. Customer will think your software is great when it does what it's supposed to do, and make your code as smart as you are, from customer perspective and the program's perspective. You and coworkers think your software is great when it's easy to maintain, use, and extend. Okay, so based on these principles, let's think about what do we need to modify that program. Okay. So this is a point here. What was wrong with Rick's original Guitar Store application? It was designed without any abstraction. All of the guitar components were defined in terms of their implementation. That means the strings. Okay, it didn't meet the customer's needs. No multiple choices. The customer actually needs multiple choices, because when you search, you want a list of guitar, so it's multiple choices. It was poorly designed with too much dependencies between the classes. We don't want this. We will maybe mention this tightly, loosely coupled thing maybe later in the semester. But here, remember that if one of the class depends too much on the other class, it's usually not a good design. Okay, like the search function. Okay, the search function inside the for loop, it called the guitar class, the function in the guitar class, 4 or 5 times. Every 3 lines of code, it calls another class. So that means there's too much connections there. For now, just remember dependencies. Too much dependencies is not a good practice. Okay. And good software, yes, satisfy the customer and the programmer. So when you design the software for that guitar store, so this is the steps. Okay, this is steps. Or this is the principles you want to keep in mind. First, make sure does the customer want it to do. Second, apply OO principles so that it fixes the flexibility issues. And then strive for maintainable and reusable design. Now let's look at the example again to see how can we fix this. Alright. Just the same, make sure your software does what you want to do. Show this all at a time. Okay, so 3 steps. First step is satisfy the customer. So here we kind of want to make it return a list, right? Okay, so first thing we does is we see all those strings Right, so here instead of using the strings, we are trying to define the enum type, like what you just mentioned, right? You have a restricted selections here. So what is enum? Everyone knows what is enum, right? Good. Enum. Okay, enum is basically just this type, predefined type of some category. Here, okay, enum type. We have two types: acoustic guitar and electric guitar. And builder, the enum builder, it has those different types, and wood has different types. Okay, elder is only one of them, and it has a lot of different woods, which make different sounds, a little bit different. Yeah. Okay, and we have a toString function. That's okay. We don't talk about that now. It's just given this type, we return the corresponding string. That's okay. If you want string, you can use this toString function. But here, instead of only string, we use the enum, so that it helps us fix that string comparison problem, right? Like big case, lower case. Okay, case is only the problem. It's the only problem. Sometimes you misspelling, right? You do misspelling. That cannot be fixed by the two lowercase. So enum helps you to solve this problem. It will return something. The customer wants you to return something.
What if there is some other type listed on the,
Yeah, that's a good question.
So for the first one.
So do you think it's very hard to extend this enum? Do you think it's hard to extend? No.
All you have to add is the new type.
Yeah, all you have to do is put a new type there, right?
Or if you don't, even if you don't want to put it in an enum, you can just use it by itself. This one is helping to group all the related strings into one unit. But if you have just one item, for example, model, that it's by itself, you're not comparing it to anything, you can just use that directly in the search function. Is that a good way to do it?
I don't quite get that.
I'm just building off of what he said. So if you have another type, another string that you need to put in the search function, that you didn't add to
Okay.
any of this.
So his point, yeah, you have another type like builder type, wood, and something else, some other attributes.
Yeah.
But what he mentioned is, if we have a type other than acoustic and electric, that's what you mean, right? Yeah, that's what you mean. Yeah. So if you have a third type, you just put it, just modify this enum,
So
right?
that way you have to edit the code, right?
Is there any way to customize?
Right, you don't have to touch the code. You don't even have to touch the code to add another function, another type, right?
No, you have to modify it, especially when you have those strings.
Okay, that's
That's
a
a
two
string
string.
function.
I mean, outside of this enum, in the search,
Okay. Yeah.
you don't have to touch the search
Yeah,
at
but
all.
then it won't find a match, right?
No, once you modify the enum,
Yeah, you have to
you'll be
modify
okay.
the enum.
Then you'll be okay, you'll find it.
Yeah, but that's what, then.
No, what he's saying is outside the enum, you don't have to modify outside the enum.
Yeah. Yes.
Yeah.
So once you have this enum, if you want to use this like type, you just need wood dot Indian rosewood wood dot outer. That will have some value there.
But I mean,
For
this
comparison.
would not be a very good design, I feel. Right, like if you're hard coding in the code, and currently there are only two types of guitars, like acoustic or electric, and the third type is introduced, you're doing add a guitar which has another type of has a different type. Then we need to go and edit the code to change the CNAM type, right?
Yeah, I was thinking, is there any way the customer itself can perhaps?
Yeah, instead it would have been better to be, able to take it from the data that is stored, like the inventory.
Okay.
I don't get it.
But
Yeah.
you don't want the customer to be able to
No, not the
edit things.
customer, but the owner of the application.
But I mean, when you look at it from like a realistic point of view, there's not too many different types of guitars. I mean, you don't have like a bass guitar or something. But
Right,
it's
right.
simple enough just to add it in there.
Yes, that's a good point. So sometimes we want the functionality. Some maybe customer want to define a new type or somehow like that. Yeah. Let's stay. If you remember, we right now we only have a horrible program for Rick in the store. It returns nothing. Okay, let's reach there step by step. Okay, let's reach there step by step. Okay, it's good to have that functionality, yes, but that's gonna be another implementation. Like what you want to say is like Rick can define a new type.
Yeah, like
Rick can define a new wood, something like that, right? So first, it's not a very common case. Acoustic, electric, another type. It's not very common.
like a
happen.
model, he's
Yeah.
Getting a different kind of like
Yeah,
a different
hybrid.
model.
Okay, yeah, that happens, but it's not happen all the time, and we will reach there. If that's something that changes frequently, probably we have another way to deal with that. Okay. But here, the assumption here is, okay, these are fixed most of the time, fixed. Okay, so this find guitar tester. Okay, yeah, that's a new program. Well, in the tester, instead of specifying all the strings and check really careful about spelling and cases, right now what you need to do is only the builder.fender and type.electric and the wood.elder, wood.elder. That's basically two types for the top wood and bottom wood. Okay, and here, if you watch here, we still have a string here. Alright, so the only string left for the model, since there really isn't a limit set of this, like there with builder and wood. Okay, so that kind of answered what we just talked. Here, it just leave it as string, so that it's sort of different. So we have a limited set of builder, we have limited set of type, but we don't have a limited set of the model, because model is pretty dynamic. But compared with model, the other things, they're kind of fixed. If you want to extend that, you can do that in the code, but not happen so frequently, right? Maybe it's another version of the software, something like that. But this happens quite a lot. Maybe you get new models every day. You cannot like ask for upgrade of your software every day. So here it's leave it as a string. There are some ways to do this, of course, like the user define the type. That's a more complex design here. Right now it's a simple design for Rick's store. Okay. Right now the only thing is here, the only string is the model. And here you can see we changed search guitar dot get type not equal to guitar dot get type. Here we directly compare the type instead of the string. Yes, so that totally avoid this misspelling and the lowercase uppercase problem, right? So yeah, to lowercase, but here we still have a to lowercase. That's the model number, because we need to do that. But yeah, we kind of trying to avoid this as much as we can, right? So we just, this is a good thing about using the enum here. Okay, so first it fixed one bug. At least it can return something now. And what the customer want is another thing. What the customer want is actually list. So the customer wants to search for a list of guitar instead of just one. Okay. Okay. Here, before that, here is a new picture of the class diagram of the system. So here, the main change is here. It's no longer strings anymore. It is actual type there. It makes more sense. It matches our logic more, right? Because when we think about this world around us, we're like grouping things, giving type to each individual object. It's furniture, those things. We don't just say furniture like string in our mind, right? We use type. And when we compare, okay, they're the same. They are a furniture store, right? Type of furniture store. So
builder is now a class, right? Builder is a class.
Builder,
Yeah.
the constructor.
Class? Is that an enum class? Is that an enum or is it
Enum.
the builder? So, if you have a
Oh, you mean here?
Yeah.
Yeah, builder is an enum. Builder type would there or enum. Yeah. So first step, make sure does customer want it still. Come on. Okay, so here it talks about the list. Yeah, after this modification, this software become better, a little bit better. So, Rick, I thought it was perfect, but then I realized I have two guitars that Aaron would love. Could you make search tool return both of them, right? That's the case. Let's say why. See, so there, since there's an example of two different guitars, like similar price, similar settings, maybe customer prefer one over another, but you have to provide these options for the customers. Let's see, Rick's customers want choices. Okay, so what we want to do is to modify this search. Instead of return a guitar object, we return a list of guitar object. We still send in the guitar object which specify the conditions, but we want in return a list. Okay, so here is the thing. Alright, let's do an exercise. We're starting from this code template, trying to modify that to make it return a list of guitar object instead of one. Let's do this in 5 minutes.
Is it interactively or is it, are we doing it interactively?
Okay, I want you to take out a piece of paper, write it on the paper.
Are you submitting it?
No, not submit, just in class exercise.
10% of your final grade. There's no extra
That's
credit.
that's too easy for 10%. One, two, three, 4, 5, 6, 7, 8. 8 words.
If you scroll down, you see the words.
I don't want to let you to see the words. I just want you to write it down. You can do it, right? Okay, 1 more minute. So we're almost, class is almost over. Okay, let's do this. Okay, if you have finished, like, say it. Just say it, answer.
List.
It's crazy. I won't put it on there. Okay, that's fine. Here,
So list.
list.
Whatever you want to call it,
Whatever.
guitar list.
Guitar.
Guitar list.
New list, right?
New list.
Okay. Oh, I screwed this. It's fine. here. Oh, where are the answers?
Going down to the next one.
This one, sweet.
Okay, it's fine. That's what's in here. Guitar list. Here. Add. Yes. Here.
Search guitar.
Oh, the guitar.
Guitar.
You're adding
Guitar
guitar.
list.
Yeah.
Now we're adding guitar.
Add what it add is the guitar, not the search guitar. Search guitar is a condition. Guitar is actually the guitar that passed all this test. That when it reach here, it's added into the list, and then you return that list. Right? Yes. Okay, pretty nice. And actually, I believe we need to use linked list or array list, something like that, because that's actually the basic,
That's what I was gonna say.
the implementation of the list. Okay. Okay, I messed up with the book. Nice. Okay, that's the step to do this.
I have it.
I don't want to mess it anymore. Alright, let's look back here to see what if I miss anything. Yeah, so basically we finish this first step here. How do we fix the guitar application? First, use abstraction like the enum, and then we fix another thing to meet the customer needs, that is return a list of the guitar. So we finish the first step to build that software, to rewrite the software to make it good. Like we still have two steps, second step and third step. Second step is apply all principles. Third step is we kind of use some patterns. But the second and third step, they are based on the perspective of a programmer, designer, so that it can be, what's the keywords? Easy to extendable, yes. Maintainable, usable, yes. So that's what we want to talk Wednesday. Yeah. Thank you.